FBK, we're looking at the 3D and the 2D data analysis. And it's really important to make a distinction between these types of data. So the 3D data, we're looking at the point clouds, sort of the higher level structure, say, of the forest that we're trying to decompose. Where are the trees, where are the plants, and giving the drone the ability to navigate through this very difficult environment. So this is one aspect of the work we're doing in FBK. The other aspect is looking at the high resolution cameras in 2D. We're looking for the details. So we're looking at where are the berries, what type of berries they are, what stage are the berries at, what's the density maybe of the fruit in that area. So for that, you look at every single image, and of course you have to, with the machine learning algorithm, understand exactly what you're looking for. But then these algorithms will provide insights to the pickers, so not necessarily for how the drone flies through the forest, but this is for the individual pickers themselves, understanding where the best places to pick, for example. So what FBK has been doing since the acquisition campaign in Finland is to analyze this data, apply state-of-the-art algorithms, look at where are we now looking at this data, and how can we apply our new techniques to improve the accuracy of the algorithms. Of course, it's really important to think about how the outcome of this data analysis will be used. For the navigation through the forest, it has to be in real time, so you have to use different algorithms when you're implementing your solutions. But for the understanding where the berries are, you can use more, say, intensive algorithms, because it doesn't need to be done in real time. You're analyzing data offline and then creating these maps. So we're trying a broad range of solutions, ranging from fast solutions to more detailed, in-depth analysis. So essentially, FBK is doing both the real-time and the offline processing of the visual information.
Tell me a little bit more about the challenges that you encountered so far.
Yeah, I think some of the challenges that we expected but didn't anticipate would have such a big problem is when you fly drones quite low, underneath the canopy of the trees, but also quite close to where the berries are, you create this downdraft from the propellers of the drones. And what this does is it disturbs the images of when you're looking down. Sometimes the berries are visible, sometimes the berries are not visible, depending on where the wind is blowing the leaves, for example. So if you imagine a drone flying through an area, and you're looking at images sequentially, maybe one every second, for example, you're going to see the same area twice, but sometimes the leaves are going to be covering the berries, sometimes the leaves aren't going to be covering the berries. So you have to be very careful not to double count berries or miss berries as you're going over. So we're going to have to develop strategies that don't just look at the visual information, one frame, count, that over time analyze whether you've seen the same area twice, therefore be careful not to double count, so you're not overestimating or underestimating the yield. So this is going to involve a little bit of interesting research, I think, to look at the temporal aspect as well as the instantaneous observations.